Board. Okay, welcome to the May edition of the Pacific Planetarium Seminar. And today we have Mary Holt from California Academy of Sciences, who's going to treat us to a little presentation. Mary.
All right, thank you everyone for joining me today for our PPA seminar. Again, my name is Mary Holt. I'm one of the, or actually our only at the moment, senior presenter at the California Academy of Sciences. So I'm one of the full-time people on our presenter staff. Let me share my screen for you. So that means I help to make a lot of the live programming that we do at the Academy. I help make our Hofeld Hall presentations, which are live presentations in kind of a wall planetarium, so to speak. Also help with the live sections that go in our pre-rendered shows, and help with other live programming, training of presenters, that, including school shows, which we'll be talking about today. And I'm going to share with you all how we developed our relatively new school shows that are aligned with the NGSS, the Next Generation Standards. And show you a good portion of the shows themselves, and talk about how we do them and how they've been received so far by students. But let's start out with some backstory here. So before we made the shows that we have right now, we were using the Digital Sky 2 software. So this is an example of kind of the interface that our presenters had for the shows we had before what we're doing right now using UniView. And this is one of the pages from the 3rd to 5th grade show that we used to give, which was a tour of the solar system. So we would start out looking at the night sky, looking at planets we can see in the sky, looking at the sun, looking at constellations, and then we would go to each of the planets and learn something about each one, and talk about telescope observations and how those have changed over time. And then for our 6th to 8th grade show that we used to have, we would start out talking about satellites and what they teach us about the Earth. We would explore the electromagnetic spectrum, talk about distances and light speed, and we would also visit planets and spacecraft in this way. And these shows ran for several years and were pretty well received over that time, but they did have their issues as well. Many shows do. There were a lot of different people that were putting their fingerprints, so to speak, on the shows, often changing different aspects of the shows without documentation sometimes, which led to some kind of disorganized and complex programming that we ended up with, which caused the shows to break a lot. Plus, at the end of the 2015 school year, we also found ourselves to be in a little bit of a predicament. For one thing, our shows were starting to show their age. They were not really keeping up with the relatively quick changing science and astronomy. For example, it was getting hard to explain why New Horizons wasn't much past Jupiter at the time. Plus, California was starting to implement the Next Generation Science Standards, and this was moving around the different ages and grades that had astronomy-specific content that were coming to visit planetarium. So it was becoming harder for teachers visiting our planetarium to get approval from their administrators to come on field trips with more justification. So,
Mary,
yeah.
Can you lean into the, their sound was getting a little bit choppy, so lean in a little bit.
Okay, yeah. Is that better?
Yes.
Yeah. Yes, okay, cool. So we found that a solution to this would be to just totally kind of rehaul our school shows so that they were both up to date with the current astronomical science and also in line with the NGSS. And we decided, but also still maintaining some of the interactivity that we had with the previous shows that helped to make them successful in the past. So we decided to take a different approach as well to the structure of these shows by narrowing our focus. So the previous shows were very long. They addressed pretty much every single astronomy-based standard that were there for the grades that attended. And we decided with the 2nd generation of shows to hit fewer standards, but narrow in on the content that was more spatially difficult to understand in a classroom and easier to understand in a dome and visualize in a dome as while still addressing those different cross-cutting standards of the NGSS. And the reason we were focused so much on the NGSS is because how wide it was being distributed. It was being adopted, or at least partially adopted, in more than 40 states, being adopted pretty widely in California as well. And we hope to make these new shows not just to keep up with San Francisco and California standards, but also to share with others. We wanted to make these shows so that we could share UniView assets, profiles, but even for non-UniView users, we wanted to be able to make a show where we could share the script and people could adapt it to their own flow and their own style, their own presenters, and add new science content available. So this meant working with our engineers to make a show base that could be built on with add-on modules and ensuring that our presentation was sound in both educational content and pedagogy as well. And we were able to accomplish this task because our institution is pretty lucky to have a staff of both engineers that understand UniView really well, as well as a team of educators who are really familiar with bringing NGSS into classrooms, as well as familiar with the formal museum setting. And our senior presenters worked together with both of these teams throughout the whole process to develop the shows and ensure that we were creating shows that utilized helpful assets, followed the standards and pedagogy and things like that. So we started out showing our education team what we had, and we emphasized elements that we thought were successful before, what we thought was fun and necessary parts of the shows. And after we identified those elements, we turned to standards, found portions that best fit for the dome, and kind of used that as a scaffolding to build our scripts around the standards. And the early script was looked over by the educators, and they helped us to kind of delineate those complex concepts and address them in a more easily processed way for students, and make sure that we were giving adequate time for more complex ideas like that. And one of the things we learned too was that after 3 different iterations, we were discovering that the show we thought was targeting 6th to 8th graders actually turned out to be better for the 3rd to 5th graders. So we had to adjust our approach kind of midway through. And as the educators provided us with focusing on the NGS standards that were important and the pedagogy that would be working well, we also worked with the engineering team, sat down with them to see what assets and storylines that were relevant to the topics, and these were turned into demonstration profiles that we would bring to the meetings with the educators, and an engineer would fly and show the different assets while a presenter would explain the visuals that we were seeing. And like most things, it wasn't easy every step of the way. There was some skepticism from our presenters at some points of whether or not these techniques that the educators would use in the classroom, if they would translate well to the dome, but we were pleasantly surprised with how well the pedagogy worked. So let's get into the shows themselves a bit here. So that's kind of the background, how we sort of built up the shows. But the shows themselves and what was different about them, one of the big things was a big emphasis on think, pair, share. So our educators thought it was really important to use this technique of the students thinking about what they're observing, they get into pairs and talk to each other about what they're observing, and then they share with the presenter, with the teacher, what they have observed. And one of the ways that we were able to make that successful is by making sure that we always address this before the show even starts. So before I even go up into our control booth, when I'm still out in front of the kids, I go over how we're going to answer questions throughout the show. So I say to them, if you were asked a question in school, what would you do? Many of them say, you answer it, but usually try to lead them to, you would raise your hand. But in the planetarium, it's relatively dark, so if you raise your hand, probably not going to be able to see it very well. So we do want them to answer it out loud, but only answer one time. Stay nice and quiet after that. So I usually do a test run of asking them what their favorite planet is. I get a lot of repeated yellings of what people's favorite planets are, and of course a lot of Uranus and things like that. which I wait patiently for a second and let them yell out their answers and then say, okay, that's good. I think we're hearing some voices more than once though, so let's try that again one time and then stay quiet after that. And the second time, they're always much better and do it very well. So it's like, okay, so that's how we'll answer questions throughout the show. And not only do we ask questions throughout the show, but we address with them that sometimes we'll have them discuss with each other what they're going to be seeing, because we really wanted to focus on treating the students as the scientists. So they are the scientists using the planetarium as a scientific model to see, make observations, observe different patterns we see our solar system and beyond our solar system. So that's kind of the preface that we give before the shows themselves. And then I can go into actually showing you the shows a bit. And as I go through this, I'm not going to be sharing the buttons I'm going to be showing, but let me show you them real quick so you know what I'm going to be working with. So this is the interface that we use, this HTML page that will bring us through the different assets that we're going to be looking at in UniView. And if anyone has any questions about that or wants to see that afterwards, switch us over to UniView here to show us some of the shows themselves. So with the new 3rd to 5th grade show, we'll start out with that one. This is one that we give pretty frequently. Right now we're giving it often 3 days a week, and during the school year at least a couple times a week. We give our kindergarten through 2nd grade show a couple times a week as well, and the 6th to 8th grade show tends to be once a week, usually in the fall. And we didn't change our kindergarten through 2nd grade show at all because they didn't really change with the NGSS stuff. So we're just looking at 3rd to 5th grade and 6th to 8th grade today. But with the 3rd to 5th grade show, the main focus is using the planetarium as a model to observe patterns, observe cycles that we can see. So we start out here on Earth, and we start out in Golden Gate Park. We can see the California Academy of Sciences over here. And I always have them identify where we are to start out with and usually respond with, that's right, we're on Mars. And they'll laugh, what are you talking about? And then they have to explain why we're not on Mars and what they can see that shows us that we are in fact on Earth. Like blue sky and trees and buildings. But then we address, well, what can we see in the sky? We can see the sun. It shows us that we're looking at daytime sky. Do you see any stars in the sky? Well, the sun is a star, but those stars that we normally think of as those little points of light that we see at night, we can't see there during the day, but it's not because they aren't there. And we show that we can use the planetarium as a model to show why we aren't seeing the stars during the day. We can get rid of our atmosphere. We usually have everybody take a nice deep breath before we get rid of the atmosphere to make sure that they stay alive, and show that those stars are always there. Just the light of the sun is being scattered around in the atmosphere, making it so we can see them. So once we've established what we're looking at here and what time of day it is, that we look at the cycle of how the sun appears to move throughout the sky. And one of the ways that we have the kids be the scientists in this situation is they predict where they think the sun is going to go. So they actually have them trace out with their finger where they think the sun will move in the sky, whether or not they think anything else will move. And then we have time to go forward and see if our hypotheses are correct. The sun going by and the moon going by. Get a lot of oohs and ahs when the stars pop up. And then the sun comes back to where it was before, and we discuss how this is what we determine as being a day cycle, is this cycle of the sun rising and setting and coming back to where it started. And the sun is, of course, not the only, and this cycle is not the same throughout the year as well. So we can show, for example, where the sun would rise in the winter, where it would rise in the summer, where it would rise in the spring. It's make predictions for how that's going to change, where they think the sun is going to go. But that this cycle is always 24 hours. So if you have a shorter daytime, longer nighttime, vice versa. And then we move on from there to show that the sun is not the only object that makes predictable cycles in our sky. We can also take a look at the moon, see that the moon is constantly changing how it looks and where it is from night to night. So we switch from going one day slowly at a time to jumping forward one day at a time. Switch to putting up what day it is, and go through different moon phases, have them identify which phases they are. And then we talk about how long this cycle is and how long it takes for us to see all of the different phases, and that determines what a month is. So we've got our day cycle, our month cycle, and then we move on to a year cycle. And I like to discuss with them a little bit of, well, how can we determine what a year is? We could count 365 days. That would take a long time. We could count how many months it would take, but again, it would take a long time to observe 12 months going by. But one way we can determine what time of year it is by looking at stars. And so we can look at these different seasonal constellations to tell us what time of year it is. And you can harken back to the beginning of the show at this point, be like, again, these stars are always out there. We're just seeing different stars at different times of year, because sometimes these stars are up during the day, and like we saw before, our atmosphere makes it so we can't see stars during the day. And we go through and show just one prominent seasonal constellation per season. So we have months going by here. You can see the moon going by to show that months are going by. We've got Orion. We do have the pictures of the constellations in the actual show that are out there on this profile. But we got Orion and Leo. We have Scorpius the Scorpion to show our summer sky. Go back to fall. Pegasus once again. And then that's kind of the first main section of the 3rd to 5th grade show, but then we switch our focus here, talk about how we are observing all these cycles on Earth, but to get a better idea for why they're happening, a good place to go is totally outside of our planet entirely. So we can use the planetarium as a model, not just the sky, but a model of outer space as well. So we take off from Earth and go kind of in the same order that we did from looking up at the night sky. So we start out pointing out where we are. So we've got San Francisco right over here, a little marker to show where we were looking up from. And we can see that now that we're out in space, the reason we're having a day, for example, is because of the Earth rotating. The Earth is constantly spinning, changing where we are on the Earth and what we would see in the sky. So if you're on the daytime side, you would see the sun up in the sky in that blue atmosphere, and if you're on the nighttime side, the sun. And I always like to have the kids say apple when they think that sunrise or sunset is going to happen, and you get a nice crescendo of apple around here that dies down as we go by. And then they continue to say apple throughout the rest of the show while I'm here too, which I usually have to quiet them down from. But so we can see that this day cycle is just because of the rotation of the Earth, but that rotation is not, or rather, how those days happen, like we saw on Earth, are not the same throughout the year. So we show that we're rotating on an axis, and depending on what time of year it is, that axis is tilted either towards or away from the sun. So usually I go to a specific day and have them try to figure out what day it is. So with here we would see that the sun, or that we're tilted away from the sun, and try to observe how it looks like San Francisco would spend more time on the nighttime side, which shows us that we're looking at winter. So first day of winter, we can go through the different seasons. We can go over to the first day of summer, for example. Obviously, these many days are going by as we do this. See, we're tilted towards the sun, and also talk about how seasons are different depending on which hemisphere you're in as well. So that's our day cycle, and then we move on to going back to the moon cycle or our month cycle and seeing why that's happening from out in space. So we zoom out quite a bit so we can see the orbit of the moon around our planet. And always make sure to point out that I'm making the Earth and the moon much bigger than normal, so we can see more easily, and show that the moon is always halfway lit up by the sun and half dark, but we see those different phases because the moon is orbiting our planet. So again, all these cycles we're seeing are because of the Earth and the moon, not because the moon is changing shape, not because the sun is actually moving throughout the sky, but because of these different motions that we're seeing. And then we have our day cycle, our month cycle, and then we move on to our year cycle once again. And we can see that the reason that we're having a year go by is because we're going around the sun. You can see our Earth orbit around the sun here. Earth much bigger than normal. Pole once again. And I usually, again, go to a specific day of the year, have the kids try to guess what time of year it is based on which constellation on Earth. So if you were standing on the nighttime side of Earth, you'd be facing over this way and be able to see the stars over there, not be able to see the stars over there because of our atmosphere again, the sun. We go through like that. And then it switches again to kind of the next portion of the show where we talk about how these models we've been using, cycles we've been talking about, have all been based on our Earth perspective here. But that doesn't mean that we can't use these models or use these cycles to understand other places outside of our own planet. So we go from understanding these cycles on Earth to applying them to other places in our solar system. And this is kind of a nice portion of the show in the sense that the presenter can kind of choose where they want to go next. We have a few different options of where they could go. They could go to the moon, for example. They could go to Venus, they could go to Mars, or Jupiter, and observe what these cycles would be like on those other planets. And I personally like to go to Venus because I always like to fly over to Venus and have them discuss with each other what they think a month would be like on Venus. Then I get some of their feedback, and it's always mixed. I hear a wide range of answers of, oh, this many days, or this many years, or it's 7 months, or something like that. I guide them through, well, how do we figure out a month on Earth? Based on the moon. There's no moon here, so we have a month. So this this month that we're talking about is largely based on our planet and would be different if we were going to. And for a day cycle on Venus, we can show a comparison to Earth's rotation and see that Venus has a very, very, very long day. It rotates extremely slowly. And for a year, you can zoom out and see how, as you go to different planets, the farther you are from the sun, the longer your year is. And the year is just determined by how long it takes you to go around the sun. And from there, we usually only have time to go to maybe 1 or 2 other planets or dwarf planets in our solar system. Usually go to Jupiter to give a gas giant kind of perspective. Jupiter has a pretty wild month as well. A lot of months to keep track of. Or you can go to Pluto and see how Pluto and Charon are orbiting around each other. Very odd day. But then from there, we end with kind of a final section of, okay, so we've seen that we can use these models on Earth. We can apply those models to places outside of Earth. But it turns out we can use these models and these different cycles to describe places that are completely outside of our solar system as well. So give a little preface to the fact that there are exoplanets, or planets outside of our solar system that we can observe too. And we can visit one of those exoplanets and have them discuss what they think those cycles would be like there. So one of our favorites for the 3rd to 5th grade show is Kepler 16b, which if you're familiar with Kepler 16b, you might be guessing why we like to go there, because as we can see as we zoom up, you can see that Kepler 16 has 2 stars. And so if they were trying to determine a day, for example, on Kepler 16b, it would be a little more complicated than here on Earth because we have 2 sunrises and 2 sunsets. If you want to make a reference to Star Wars, there's your chance. So that's kind of a quick overview of our 3rd to 5th grade show. So it's really, really focused on cycles and patterns. And for the 6th to 8th grade show, we start out in a similar way. We start out on Earth, looking up at the sky and identifying where we are. But very, very quickly, we leave Earth behind and go out to observe what makes Earth Earth-like. So we see Earth has an atmosphere, it has life, it has these continents, it has a lot of water on its surface. But what were to happen if we were to kind of peel apart these different layers that make up the Earth and compare them to other places? So talk about the Earth as being composed of these different layers and spheres. So for example, if we were to get rid of the Earth's atmosphere, what would that look like? Have no clouds, we would not be able to breathe, that would be bad. We get rid of the glow that we were kind of seeing around the edge of the Earth, and we go on from there. So we've got our atmosphere, this layer of air that we have around the Earth. We also have a biosphere, so what were to happen if we were to get rid of life on Earth? We would see all that green go away. We would see our lights from our cities and towns going away. What would happen if we were to get rid of our hydrosphere, get rid of the water on Earth? Then we can really see the Earth really is a rocky planet. There's a reason we call it that. Mostly of its lithosphere, this rocky layers. And it's not just the surface layers either. The surface layers and how we observe the surface of Earth can also teach us about what's going on inside of it. So we can show locations of volcanoes, earthquakes aren't showing up, I don't think. But earthquakes and volcanoes, which can show us where tectonic plates are around the world, which teach us about the interior of the Earth. And we show that those layers go very deep, show all the different layers of the Earth. Around, we have the labels of the different layers of the Earth as well. And those interior layers affect not only the surface of the Earth, but also another invisible layer, magnetosphere. So it's a different kind of sphere that we have at the very edge. And from there, again, we have a little bit of flexibility of where to go next. So we can go to a few different other planets in the solar system. We can go to Venus, Mars, and Jupiter and show how they're, like, talk about how their layers are different or similar to Earth. For example, Mars, fly over to Mars and show that it does have an atmosphere, and what would it look like if Mars had an atmosphere. It doesn't really seem to have a hydrosphere at all, but that wasn't always the case. Show what Mars looked like in the past, show that it did used to have a pretty prominent hydrosphere in the past and a bigger atmosphere. And as we go to each of these planets and visit them, we also visit recent spacecraft missions that are the big reason why we know about a lot of the things we're looking at, how we learn about these different locations. And I don't have the spacecrafts on here either. They take up a lot of space, so we didn't put it on this particular profile. But then to end the 6th, 8th grade show, we kind of end in a similar way to how we do with the 3rd and 5th grade show by giving perspective from outside of our solar system. And a really big favorite for this is 55 Cancri, because it really kind of throws all those different layers for a twist, because 55 Cancri is so close to its star that we think it's a pretty unusual, weird place. So we talk about, like, water layers, hydrospheres, we talk about atmospheres, lithospheres, and all these different layers, and really this may have many of those, but it's all encompassed within a lithosphere. It may have liquid rock on the surface, and lakes, rivers of sorts. It possibly has rock rain, which is really cool. So it does have these different layers and these processes that we can compare to Earth, but it's in a very, very different way we have on our own planet. So that's a really quick run through of shows themselves, but you may be wondering as well how they've been received. So from personal experience, I will say that the kids seem to have a lot of fun with these shows. I've personally given the 3rd to 5th grade show the most, and the question and answer seems to work really well, and having them discuss with each other works really well too. But I'm biased being the presenter, so we don't just rely on our own perspective. We've also conducted some surveys for the different teachers that have come to see these shows and see how these new techniques are working and whether or not we are in fact hitting the standards that we're hoping to, and providing good content for the teachers that they will want to continue to come back. So we have a few examples here of some of the questions we've asked for the 3rd to 5th grade show about the next generation science standards and whether or not we're hitting those. And we've gotten some mixed responses here and there, but overall it's been pretty positive. So these are some of the responses we've gotten for some of those questions. So overall, we have strongly agree that they are following the standards that we are trying to hit. The 6th to 8th grade show, we had, we're focusing on like how scientists learn what they do, and that we have these different layers on the Earth and other places. And also with that, we've gotten pretty positive responses, but we do want to continue to give these surveys. We've only had a few people respond for the 6th to 8th grade show so far because we get it a little bit late. And also we just want to make sure we're keeping to make sure these are up to date, following what and here are a few examples of some quotes we got from some of the surveys. One of my favorites is the person that mentions the kids liked being air sick or getting a little bit of motion sickness, which I thought was interesting. But some nice feedback that we got from some of the teachers. And again, we want to continue to improve these shows and continue to add on to them as we need to, and to continue to do this not just for us, but also to share with communities. So we want to do things like this, like the webinar that we have today, and also we had the Pleiades presentation that Dantel and I gave back in October, and we want to make this accessible to everyone. We want to, if anybody's interested in seeing the scripts or seeing the profiles or sharing the profiles or sharing what they do in their school, hear about it. So that is pretty much all I have here, and I'm ready to discuss any of that with everyone and answer any questions that you all might have.
If everybody wants to unmute, it'd be appropriate at this time to show our appreciation for Mary. That was a great presentation. We'll have a round of applause.
Thank you.
And hold on one second. I'm going to